Good morning, everyone present here. So, today I'm going to give my presentation for my data oral exam. So, let's start. This is the outline what my PPT consists of. So, there will be 4 questions. I'll be answering to those. Starting with the first question, it is perform ANOVA testing for the given data set. Now, before go jump on directly to the code, I would like you to know that what is ANOVA testing, why it is done for, what is its purpose. So let's get started. Now, ANOVA test, it stands for the analysis of variance test. Now, ANOVA test, it is a tool for statistics that is concerned about the means of two groups of data set. Now, these groups of data sets, their means of these groups of data sets are compared using this ANOVA test, and to what extent they are going to differ from each other. Okay, so now if I need to give you the example for it, I would say like when if you take the data set of voter, then we can differentiate the group between them in voters, like their age, their race, or from where they belong. Okay, so you can differ it from them. Now there are various types of uh, data, like we can data test. So there is also t-test, which is used to again compare the means. But if you run t-test again and again, it will give you more false positive, like it will be very complicated, or it can give you wrong value. So ANOVA test is it is used where you have to perform the means from multiple, three or many more data sets. Today we are going to use three, so but you can use also multiple data sets. So it helps us in comparing the means of multiple group at the same time. Now there are some assumptions that need to be followed whenever you are going to do any ANOVA test or any test. There are some means to be taken into consideration. So for here, as you can see on the screen, the first one, it's like normality. So what does normality means? Each and every data set should be drawn from the normally distribution. Now if you take an example, we have prepared the set of papers from which there is an exam, and you have prepared online preparation set. So there are MCQ, but there are three different sets, and you have to perform, you have to see whether which is the most efficient a pre-examination test that student can use. But there are thousands of students all around the country. So what would you do? So like ANOVA test, you can perform like take 100 sets of 3 sets of 100 students, and you can give that test to them so they can write it. So now here you have to take consideration that uh, every student means that test is for commerce, then take it for commerce. Now it should not be like one set of students is from commerce, the other set of students is from science, and the third set it's from other country. So it should not work in that way. So each set should be from normal or equal thing. Now second, it is equal variances. Now the population standard. Now you cannot say that one every question that you have prepared or set is for different subject. It won't work here. Like one set you have given, it is for different subject. The other set you have given, it's for different. It won't work here. Now independence. The observation in each group are independent of that each other, and the observation within the group were obtained as a random sample. Okay, now p-value. P-value, it is very less. If you go manually, for if I would go manually to explain ANOVA, it would really take very long time because it's really very complicated. But Yeah, p value, I could just tell you that p value is, if you choose p value, if the p value is less than your significance level that you have choose. Suppose for example what I have given before, that we are preparing test for that data set, if I take 0.05, all right, and the p value is less, then you can reject, and reject the null hypothesis, okay, and conclude that at least one of the population means are different from others, okay. But if it is more, okay, the p value is not less, okay, then we then here it is less than 0.05, then we fail to reject the null hypothesis, okay. Then you can say that the data set is not sufficient, you need more data set. Now cpi dot sats library, as I told you that if I go manually for ANOVA, it will be really very complicated. So for that, cpy and python libraries, they have already the built-in function. The library of cpy.sats has this f differentiation function, or f ANOVA one way ANOVA function. So uh, yeah, the before going again into the code, I would like you to know that which libraries we are using and for what reason we are using. So NumPy, Pandas, and Matplotlib are the more basic libraries that everyone know, and we use it in almost every code for data analysis or machine learning. So NumPy, it is basically the to deal with arrays, you can say NumPy is a library where you can deal with array or fast mathematical functions are used. Now Pandas, it is for the uh, collection of data, you can say, or the file reader, you can say, okay. So panda can be used for that reason. Now seaborn, it is for data visualization library. Please be till end of the video. I'm really going into deep for data visualization today. So here it is Seaborn, it is like mixing of all a small or basics of NumPy, Pandas, and Matplotlib. So these, it is an integrated form of Matplotlib, and it is really very helpful for data, for graphs, or for plotting our graphs, okay. Now url lib library, why we are using it here, because today we are going to take the data set from the url, using url, so we will need that way. Now cpi.sats, as I told you earlier, that it is going to be used for our ANOVA function. So without wasting more time, we'll move on to our coding section. So this, the first tab over here, it is just my details given. Now here import NumPy as P. As I told you the reasons that why we are using NumPy, Seaborn, Pandas, URL library. Okay. Now here we have here we are taking the, as I told you that we are going to take the our data sets from URL. So we are giving here the link and address of the URL. Now here what we are doing is we are opening the URL. Now I'll tell you in further video that why we are doing so. It is in one of the processes of data analysis that we are opening it, we are reading it, and we are decoding it. Now here what we are doing, whatever the array is going to be there, we are converting it into float, because we don't need any kind of errors. Before telling the next step, I would like you to show that what our store data or whatever our database looks like. Now, as I told you, it meets all the assumptions for ANOVA test that I told you before. This is B1. It's all just a numerical values. All right, this is the C. Yeah. So this is the set of data what we are going to use today. Sorry. And yeah. Now here we are creating the data frame for our store A, dataset A, dataset B, and dataset C. Now here we are melting here we are actually plotting the box plot and even melting the data. Why we are melting the data? Because melting the data means we are everything starts on the new line. Means uh, from white it goes into long data. All right, so as you can see about blocks plot, I'm going to explain it further. So these are the five variables that are used in box plot. So outliners can or outliers also can be detected from the box plot. And here, okay, now starting with our real ANOVA. Now here what we are going to do is we are taking each and every means of every data set. We are taking every mean of data set. Now here dot round 3 means it's not a very big thing. It's actually what value we are taking. Now it's obvious that when we are going to take such big data, it's going to give the very big amount of numbers, whatever the mean is going to consist. So we are rounding it off up to 3 digits we need it here. Now on the next we are taking the p-value. Now here we are going to import the statistic value. As I told you, we are going to use the cpy stats and library. Here we are importing t-test. As I told you, like ANOVA we have t-test. So here it is t-test and here it is f1v, what we are going to use ANOVA. Now here we are taking about 5 round up. So we are getting 0.32132. Okay, so this is our p-value, right, for ANOVA. Now here we are going to add some new database or data set, data set to this and see. Now as like here what we did, it's the same process what we are doing here, but just for C new. Um, Here you are putting the address of the URL that is there. Here you are opening on the second line, as you see, you are opening the data, reading it, you are converting it into float, then you are storing the database. That is again you are storing the data in data frame, that is dataset A, dataset B, dataset C new. And you can see the difference in the plot diagram between C new and C before C. Now here we are going to take the data value. Now you can see how much the p value has been differed from 0.01859 to 0.32132. Alright, so it's differed very much. Alright, so moving on to our next question, that is my second question. My second question is what is the process of data analysis? Now, what is the process of data analysis? So, uh, yeah, the process of data analysis, it is what is data analysis? It is actually collecting, transforming, cleaning, and modeling the data. Now, the data visualization is much portray the data for data visualization is used at times when you have to portray the data to for user to understand it easy way. So there are some steps required for the processes of data analysis. There are 6 steps in total, that is data requirement specification, data collection, data processing, data cleaning, data analysis, and data and communication. So we are going to see all these terms individually. So now what data requirement specification is. Now data required for an analysis is based on a question or an experiment. All right. So based on the requirements of those directing the analysis, the data is necessary to put into the analysis. Like for example, we are taking like population and their income. So suppose we are taking population and population of people, all right. So this is the data set. And then there are these specific variables that are given. Unlike for population, we can take age and income. All right, so this needs specified and obtained. So data may be numerical or data may be categorical. So we cannot define it. Data can be anyhow. Now data collection. Data collection, it is a process of gathering all the information and targeting or target on a targeted variable that is identified. Now the code that I explained you, what data frame is doing, data frame is gathering all the information on a targeted variable df. All right. As the data collection ensures that the uh, data gathered is accurate. Now what data collection actually means, it is whatever the data we have collected. So the data we have collected can be from any organizational database, or it can be any information from a web page, like what URL we have given. So in that sense, we cannot predict what our data can be, or data is structured or it's unstructured. We don't know. So hence data collection is required to proceed further for data processing and data cleaning. Now, what is data processing? The data that is collected, it must be processed or organized in a analytical way. Now, before learning anything, you need to organize the things. Like you cannot learn the previous term and just keep it back. You need to understand some terms before that. All right. So in the same way, data processing should be need to organized and processed the analysis. So now it includes the structuring the data as required. Now, as I told you, that as I told you before in before code, as we seen that we were changing the data from array to float. Now why? Because we need to process that data. All right. So it is in we can say, for an example, the data might have to be placed into rows or columns. So in a table with a spreadsheet or a statistical application, the data model might have to be created. Sometimes data available is okay to use, but sometimes data model has to be created. Now, moving on to the further slide, data cleaning. Data cleaning is the process of preventing the and correcting the error. Now, what these error I'm talking about is the process of organized data might be incomplete. It might contain some duplicates. It might contain some errors. So now these errors should be need to prevent and correct. So that's why we are doing data cleaning. For a basic example, if we go, then before it's like purifying your water, or you can say if you make a chemical, if you go in chemical lab, you make a chemical, you need to define, you need to substrate out all the elements that you don't need, or there is no need for further process for that element. So that's what data cleaning is doing. There are several types of data cleaning according to the data type that you are using. So moving next, that is data analysis. Data analysis, it's a various analysis techniques are available to understand and interpret the derive conclusions. Now, data visualization may be used to examine the data in graphical form or chart form, or you can say additional insight regarding the messages within the data. Now, data analysis, you can say that statistical data models such as correlation or regression analysis can be used to identify the relations among key variables in dataset. Now, these models that are descriptive of data are helpful in simplifying the analysis and communicating the results. Communication. This is the sixth step of data processing. It is a result of an data analysis that are to be reported in format that are to be reported in format as required by the user to support. Now, what does this mean? That whatever data analysis is there, it should be communicate in easy way to understand. Now, data analytics can choose any kind of data visualization techniques. There are such as table, there are such as chart, there are such as very uh, different kinds of graphs that you can show. Now, the analysis tools that provides the facility to highlight, to clear. Uh, Now, these the communicating messages, they are more clearly and more efficiently for the user. Now, analysis tools provides the facility to format the in table or in chart. All right. So let's move on to my third question. My third question is find the correlation matrix, plot the correlation matrix on the data set, and visualize giving an overview of the relationship. Now here you can see is a heat it is a heat map, and this heat map shows you the values of correlation. It is mostly used. Now, going on to the correlation matrix. The correlation matrix, it's a tabular form, or it may consist rows and columns. It may consist the rows and columns, so to show that the variable are correlated with each other. Now, each cell in a table contains the correlation coefficient with each other. Now, in addition to correlation matrix, the frequently utilized it is frequently utilized in the conjunction with other statistical analysis. Now, there are three types of correlation, that is positive correlation and negative correlation and zero correlation. So, we will see each term easily. So, what is positive correlation? When two variables increase together and decrease together, they are positively correlated. That means one, it is perfectly correlated. And these, for example, I can say demand and profit. As demand increases, profit increases. As demand decreases, profit decreases. So in the same way, it is a positive correlation. Now, negative correlation, when one variable increases and the other variable decreases, and vice versa, it can be anyhow, they are negatively correlated with each other, or you can see they are inversely proportional. All right. So for example, I could say the distance between the magnet and the attraction, the relation between the distance of magnet and attraction. As the distance increases, attraction decreases. As the distance between them decreases, attraction increases. That is the negative correlation, for an example. Now, zero correlation or no correlation. That means when two variables are totally not related to each other. That means when two things are not even related to each other. Like it's raining today and today I'm giving my speech. It's not related to each other, right? Or you can say you are having a cup, or the amount of tea you are having and the amount of intelligence you are having. Let's move on to my code for the correlation data. Now for the correlation, I have your data set iris. Now what is iris? It's not the pupil that you have. It's actually the here in data set. It's actually the blue color flower that is there. You can also call it as a bell pepper. So here we are going to have the data set of sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter. All right, so let's start. And one more thing, we have three different species, and we are going to even uh, deal with this species afterwards. We'll see that what happens. So let's start. Again here Here are my details. It's not that. Now here we are just taking the data frame and putting it again. We are using pandas. Panda is actually, the name panda is from panel data. So from pandas, that's from where it came. This is data frame head. What dot head does, it shows the n number of lines for your data sets to get you the glance what your data set consists of. So I've already shown you, but still once again we have these all heading: sepal length, sepal width, petal length, petal width, and the species, and everything. All right. Moving on to our next, this import seaborn, matplotlib as plot, and phase. Now, what does the phase grid? It is used for relation between the two data sets, you can say, or plotting the conditional relationships. So now here we are using the data frame, we are using the species. Now there are, as you can see in the uh, scattered graph, you can see there are three different species, that is iris setosa, iris versicolor, and iris virginica. So yeah, we are going to do that, and we are going and here we are going to uh, it is sepal width centimeter versus the sepal length centimeter. The same what we have done in our code, we are going to do it here. Like here it is matplotlib we are using. As I told you, matplotlib is also used for the graph, and it's derivated version, or you can say original version for plotting the graph in Python. Here we are taking petal length to petal width. All right. So here you can see there is a conalization in the species. Like, it's very distinct, but here everything is scattered around. All right. So that would be really deep if I go. Now here at last we have came to the pandas. Now this correlation thing. All right, so now here we are importing sklearn, and for in that we are going to take mean squared error. All right, now here, as you can see, we are using heat map. Now what is heat map? Higher the color, darker the color, higher the value. And it is really very simple to understand the complex data, or when you're comparing multiple data. Okay, so now here what we are doing, so this is how correlation variable works, like with sepal width and sepal width. Okay, so this is the higher relationship in between the variables. Now here what we are doing, it is we are replacing the species. As I told you that we are going to deal with the species, here we are replacing the species of setosa virginia with 1 2 3 4, 1 2 3. All right, and here we are going to plot them. Yeah, here, as you can see, X train we have used. So sklearn model selection, it is also a train test split. So we are splitting the data set. Now here we are going to split the data set, and we are going to change the data set. Now it is used when you have to make changes in data set online. So right here we are changing, you can see the data set. Yep, your white train. Now 1, 2, 3. You can see first we did not have this, but this 1, 2, 3 is nothing but our species. Like one is Iris setosa. All right. So yeah, we have got the output of named species. Now here we are going to check whether the classification dot fit. Now this is the value that we get, that is 0.9833. All right, moving on to our next question, that is uh, data visualization in Python. So we are going to see what is the data visualization. Yeah, what data visualization is, it explores many different ways to see the pattern. and insight. When you get a raw data, you cannot see that much specifically, or you cannot make an easy differentiation between that data just seeing the columns and rows. So data visualization gives you many different ways to see the patterns, the insight in what way or what possible way you can form your raw data, what you're looking at. The data sets become, as the data sets it's going to get bigger, the world is just uh, growing, and data sets become bigger and more complex. Only AI, co- more sophisticated codings and materialized views are able to see the insight from glean insights from them. Now, as you know that, have you ever wondered that you are able to remember your childhood memories, but you are not able to remember what was there in your fifth standard textbook? All right, that is because your brain process visual data more better than any kind of other, which is the rows and columns, because which is actually very good, because the information our brain process is visual. Now, we have three methods for data analysis. The first is univariate analysis. Second is bivariate analysis and multivariate analysis. Let's go in deeper. Now, what the univariate analysis is, as the name suggests, each and every variable is analyzed individually. It is because it gets the complete statistical data for featuring. Now, box plot, as I told you that I'm going to get in deeper with the box plot. Now, for box plot, yeah, the box plot is a chart that shows whether the form of five number summary includes one of the major of central tendency. The box plots are also very beneficial for large number of data sets. Now, it doesn't shows the distribution in particular as much as stem or leaf or histogram shows. So box plots are also very beneficial when large number of data sets are involved for comparing. Like it has five values. I can show it in the, yeah. Now, as you can see, there are five values at outliers. These are minimum, this is maximum, this is minimum, this is maximum. Here you have 25th percentile, and this is 75th percentile, and here is your medium, that is, and this is the in quartile range, that is IQR. So different parts of box plot. Box plot is also very beneficial for the when you have large amount of data, or a large number of datas are involved. So mostly we use box plot for ANOVA. You can see. Now, the outliers can also be predicted in box plot. Now, why the now histogram. So histogram, it is the graphical representation of the group, the frequency. Now, what is the difference between bar graph and histogram? It is actually the bar graph contains bar, but histogram contains the both. It has the parameters to get both, as well as the height and as well as the base can be brought according to the area. It's actually the area diagram, and it can be defined as set of the rectangles that is based along the interval between the class boundaries. Now, now, I when to use histogram, the data, when you have much numerical data, or when the data distribution, to check the shape of the data distribution, how this data is distributed, and for histogram, whether the output is different from when it involves the when the output is different from whether it when it involves two or more processes in it. So let's move on to the next, that is bivariate data analysis. Bivariate analysis is performed to it is performed when the relationship between the each feature when it is performed when the relationship between each feature with a targeted variable is there. Now data visualization techniques has a scatter plot and heat map. So as you can see, when you have to perform the two every relationship between each, you are using the an analysis, sorry for the disruption. And scatter plot are the graph that are present the relationship graphs that are present the relationship between the two variables in the data set. The represent it represents the data points on the two-dimensional plane or the Cartesian system. Now, what are the heat maps? It's actually the two-dimensional format as colored map. So the different color variation represents the different, as I told, darker the color, higher the it will be, higher the value will be there. So let's see what it looks like. This is the scattered plot diagram, and this is the uh, heat map. So as I told you, we have also used heat map in our correlation program. Let's move further for multivariate analysis. As the name signifies, multivariate analysis is performed to understand the relationship between the different features of dataset of one main multivariate analysis. Data visualization technique is a pair plot. The pair plot allows us to see whether the distribution of single variable and relationship between the two variables. Now, here it's basically just simple that we are going to pair and plot the things. So as you can see, pair plot always it's a form of 2 to 5 many other groups. As you can see here, we are actually seeing pairing the two variables, and we are going to see how much they differ. So that's it from my side, and thank you so much for listening. And that's it for today. Thank you.